12. What is the hybridization of the central atom in each of the following? And then we have SF6. So we have sulfur hexafluoride. Now, before we even talk about hybridizations, the easiest way to do these types of questions is hybridization always goes with a Lewis structure. So they gave me the compound SF6. I'm going to draw the Lewis structure so that I have a better understanding of what specific hybridization it is. So before we get down to what you have to know for hybridization, we have to draw the Lewis structure. Now there's hundreds of problems on this channel just designated to drawing the Lewis structure. So if you feel that you might be asking questions or if you need a better understanding, you could always go back to those specific questions on our channel. We have tons of them to go through Lewis structures, but this will be kind of like a quick inversion. So they're saying that one of them has to be the central element, and it always goes by electronegativity. The least electronegative element is in the middle. So between sulfur and fluorine, fluorine is the most electronegative. So that can't be in the middle. Sulfur has to be in the middle, surrounded by the 6 fluorines. So I got F. Oh boy, maybe 1, 2, 3, 4, 5, 6. Okay? So now, let's just maybe, that's better. Now we have to draw our valence electrons. Sulfur is in group 16 or 6A, so that gets 6 valence electrons. So 1, 2, 3, 4, 5, 6. And each fluorine is a halogen, right? Group 7 or 17A, so that gets 7 valence electrons. And if it sounds like a tree is almost going to hit my house, I hope I'm okay. If I finish this video, I'm safe. But I have no idea what's going on out there. Anyway, we're drawing 7 valence electrons around each fluorine. Gotta love it. All right, we're almost done here. So now we're going to bind each one time, single bonds only. So we have single bond to single bond, dot to dot makes a single bond, single bond, single bond. Everything's all good here. There we go. Okay. And now you just check your outer elements just to make sure you have the octet. But if I do check all these fluorines, they all got 8 electrons, so we're good to go. Now we take this and we do our hybridization. So they're only asking for the hybridization of the central atom, and the central atom here is the sulfur. So I don't even care about what each hybridization for each fluorine is. We're only looking at the sulfur in the middle. Okay. So there's 5 different types of hybridizations you need to know, ranging from sp all the way down to sp3d2. These are just talking about the different types of orbitals that are basically used when they overlap and make your Lewis structure. But they all correspond to how many letters they have. So for example, sp just has an S and a P, that's 2 letters. sp2 has 1 S and 2 P's, P squared. So that's a total of 3 letters. And you probably get the gist by now, right? S and 3 P's, that's a total of 4 letters, and you keep going down. Now, when we're trying to figure out what the hybridization is, just translate those amount of letters into how many things are surrounding the atom. So 2 letters means you got 2 things. 3 letters means you got 3 things going around the atom. 4 letters, 4 things, etc., etc. And here's the rule for what classifies as one thing. One double bond is one thing. One single bond is one thing. One whole double bond, even though it's got 2 bonds in there, it's still classified as one thing. The triple bond as well, and 1 lone pair of electrons. So we're going to be analyzing what sulfur has. Well, seems like sulfur has 1 single bond, that's one thing. Another single bond here, that's 2 things. It's got this other single bond, it's got a lot of single bonds, that's 3 things. Got another single bond, that's 4 things. It's got another single bond, that's 5 things, and another single bond, that's 6 things. Notice how I don't include any of these lone pairs because those are not to sulfur. They're to the fluorines. So, for your sulfur, you got 6 things going on here. So 6 things, 6 letters. That's SP3D2. And there is your final answer. So let's just box that off. So that's your hybridization of sulfur, aka the central atom. Color it in nice and call it a video. Okay? What'd you think? Thank you for tuning in. Hopefully this helped. Let me know in the comments. Subscribe to the channel, and I hope you're having a great day out there. Keep studying hard, and I will talk to you soon. All right? I'll talk to you then. Bye-bye.